All right. Sorry for the slow start. So one thing that we'll kind of do today is I'm going to do a little bit of review from what we talked about last class. I kind of went through briefly a model where we looked at revenue sharing. But I want to make sure for those last two kind of problems on the homework, we have a little bit better of an understanding there. So I'll go through that to kind of start out class with. So let me see. So I think I had shown you an example of revenue sharing where we now kind of had this additional lump sum that was being paid to teams. So it created this additional average total revenue curve, right? Because average total revenue before would have just been our demand curve, or base of our demand curve. Now, if we want to win maximize and get to this point where profits are equal to zero, just so we could kind of spend out a little bit further because we had this lump sum that was given to us, right? Average total revenue was total revenue we could earn on our own, plus this additional revenue given to us by the league, right? So we kind of talked about the differences there, and I kind of show you the average total revenue curve. But there's also something interesting going on when we have revenue sharing. So if we think about relative to like starting out with no revenue sharing, what's going to happen? So a lot of times I'll do this where I say, okay, we're thinking about the win market here. And I'm just going to keep marginal costs constant and kind of the same for both teams. We'll assume that both teams face similar costs. If we had large versus small market teams, so let's say we start out with something like this, where I have a small market team, their demand and marginal revenue curve, right? There was this revenue that's earned for every additional win. There's a certain fan demand. Maybe it's not as high in the small market. And then let's say we've got demand for the large market and marginal revenue for this large market as well. Okay. So if we're thinking about now the league decides, okay, we've got this huge discrepancy, right? Let's assume, and we could do different combinations, but for right now, let's just assume that both of them are profit maximizing. So they're both going to choose the optimal number of wins, right? Where marginal cost is equal to marginal revenue. So they're both profit maximizing, and we've got this huge gap, right? This huge gap in the kind of expected or targeted wins from small versus large market teams. How can the league fix this? So they institute some revenue sharing. And here, every team has to share revenue. And if you think about the amount of the shift, though, let's say one team is making $10 million in broadcast revenue, the other's making 100. If they both have to pay in 50%, how much has each one of them shifted? So instead of keeping the 10 million before, I now only get to keep 5 on the small market team. So I've shifted back 5 million. But if I'm a large market team and I have to pay 50%, what's that shift in my demand curve or kind of my marginal revenue curve, right? I'm going from 100 million all the way back to 50. So it depends on kind of the size of where my marginal revenue is, right? The marginal revenue a team faces is something like, 10 million per win versus 100 million per win. That shift backwards is going to be much larger for that large market team, right? So we can think about, and this gets kind of, a lot going on in one graph. So I'm trying to talk through it before I start drawing. I'm going to see a shift in both of these, but I know that if they're paying in the same percent, the shift in the large market is going to be a much larger absolute value or a number, right? So, maybe I see that demand for this small market, and I'll kind of put a little tick there to kind of notate this is after the change. So I can kind of see their targeted wins will fall, right? But I know that the additional revenue per win, yeah. So you can think about, it's not so much, I could actually not draw that demand curve in there. But the reason why, if they were win maximizing, then we would need that demand. So it's like every dollar I could have made off of demand before. So remember, think about demand represented average total revenue. And so it's almost like for every additional dollar I could have earned from demand before, now I'm only getting half of it. And obviously it's not 50% of all revenue. So maybe the way I'm talking about this is slightly incorrect because, right, that shift of 5 million, it won't be the entire demand curve. But here we're just going to say, there is going to be some shift, or sorry, I shouldn't say it's the entire demand curve. It won't be every factor that influences the demand curve, but even if I have to revenue share in one area, I am going to see kind of this decrease in my demand curve. So it may not be like the complete 50% shift. It's a 50% shift in broadcast revenue or in whatever type of revenue. Yep. So I would then see the kind of the same thing for the large market, right? But the kind of size of the shift is going to be much larger. Same percentage, but much larger size. And so then I might see something like this. Okay, so there's going to be a lot going on here. So I'm going to draw this all the way down here. So large market and then demand for my large market. Yeah.
This is for the scenario that connected for revenue share between the whole week.
Yep. So this is going to be that every team has to pay the same percent of revenue from whatever area. We'll use broadcast revenue for the example. So every team is going to have to pay in. It's not like only the top teams. It's every team pays in 50% of their broadcast revenue. So that's why we get a much larger shift in that large market versus the small, because they start out with a higher number, 50% of a higher number. Yeah. So. And, I won't try to necessarily trick you when it comes to, because like we don't have the actual equations here. So I'm really, how much is this shift? All we can say is that it's going to be a larger shift than it will be for the small markets. In which case we know now if both teams profit maximize, and I've tried to draw this, so we'll call this S tick here, or S2 if you want to, when profit maximizing for the large market, we can kind of see that gap has closed, right? Now, all bets might be off on this if teams are profit maximizing. And I'll draw a separate graph for that here in a second. But for right now, as long as they're all, if they weren't profit maximizing, but win maximizing. But for now, are we okay with kind of, if they're profit maximizing, not only will I get this additional average total revenue curve, but I'm also going to see these shifts in their demand and margin revenue. So one reason why I didn't draw in the average total revenue curves here, because remember, we're revenue sharing, so we pay in, but then we get a lump sum. So for each one of these large and small market teams, I could now draw in this new average total revenue curve. The reason why it doesn't matter is why. If they're profit maximizing, they're not making any decisions based off of average revenue. They're making the decisions based off of marginal revenue. When I'm given a lump sum amount, that means I can win 0 games or I can win 162. I get the same amount from the league, right? And so that's why I didn't draw them in here to just kind of muddy up the graph. If they're profit maximizing teams, they're not making decisions based off of average total revenue. Okay. So are we okay with just the kind of profit maximization behavior before I kind of go to the next thing here? Good? Okay. So what if instead, set up a slightly different scenario? So let's say both teams face the same marginal cost to win. Maybe I think about, let me think, how do I want to set this up? So I want to show you an example of win maximization. So let's say we've got our small market down here. And then maybe we get a larger market up here. I want to set this up to kind of point something out. So let's say instead of revenue sharing in terms of they take a certain percent, let's say the league does something else where they take some type of national contract that they've made. So maybe their national broadcast rights, instead of distributing them evenly to the teams, maybe they do some measure of market size and distribute them only to the small market teams. So we're kind of assuming a goofy scenario, but we'll see why in a second because I want to make a point. So let's assume that we've got 15 large and 15 small market teams, right? But the only money, all the money made from these national broadcasts, they're only going to give to small market teams because they know that, or maybe they believe that, if both of these teams are win maximizing, right, there's going to be a gap between my large and small market teams, right? And the win maximizing point was where demand hit that marginal cost curve. Now, the reason why was because marginal cost is constant. So demand ends up being our average total revenue curve. I think I kind of showed you, the formula there of why we know that that's the point where profits are zero. But that will be the win maximizing point, all right, where profits are equal to zero here. So they now say, okay, I'm going to give all the money that we made just to the small market teams. So now my average total revenue curve is no longer the demand curve. It's the demand curve plus this additional amount I was given. And as I win a higher number of games, the average total revenue, right? If I win one game, that lump sum, like the amount of revenue I got per game would just be, or per win would be divided by 1. Now, if I win 2 games, it's the lump sum divided by 2, and then divided by 3. It keeps getting smaller when I'm thinking about the average. So as I win more games, this average total revenue curve starts to get closer and closer to the demand curve. I might have drawn it even a little bit exaggerated here, but that's the idea. Okay. So now I think as the league, well, this is great, right? Because now if I only give the money to small market teams, now when they win maximize, they're going to push out because they have more money to spend. Now the point where the team that got the league transfer hits profits are equal to zero is where that average total revenue curve hits the marginal cost curve. Same as before, it's just now average total revenue isn't just based off the demand curve. It's this additional amount of money given to the teams by the league. Okay. Everybody okay with any questions on this? Okay.
How does that line get closer and closer?
Yeah, so think about it this way, right? If I have 100, usually we divide by quantity when we're thinking about averages. Here, our quantity is the number of wins. So if I was given some lump sum amount by the league, if I win 1 game, my average total revenue is 100. But if I win 2 games, the average total revenue per win is 50. And if I win 3 games, it's 33. So as I win a higher number of games, the average total revenue is declining. Yep. Unless my marginal revenue curve does something weird and starts to increase or something like, but the decreasing marginal revenue curve kind of leads to that. Any other questions on this before we keep going here? So what happens if the league does this, but instead of win maximizing, what if the small market teams were profit maximizing? What would change by giving the small market teams this additional money? Yeah, so where's the profit maximizing point where marginal cost is equal to marginal revenue? But notice, actually I can just call this S. So notice when they're profit maximizing, giving someone a lump sum of money doesn't change, the marginal revenue, right? Changes the total revenue, but doesn't change my marginal revenue. So they're going to keep making the same decisions. They're going to maximize profits based off the thing that they can control, which is this target number of wins. And then this additional money, they're just going to pocket it, right? So they're not going to spend this additional money if all they care about are profits. Okay? So, really what the league should do depends on what kind of behavior you see from your small and large market teams, right? Your small market teams are profit maximizing. These league transfers or this revenue sharing really isn't going to have much of an impact, right? They're just going to pocket this money. Now, what's something maybe the league could do then? If they think that they're just going to pocket money and the whole goal of revenue sharing is to close the gap in wins from small and large market teams, maybe I could earmark it. So when I give the money, kind of revenue sharing to these small market teams, one thing that you'll see leagues do is they start to say a certain percent of revenue needs to be spent on player salaries, right? Or start to kind of tie things to the money that's being given. And I haven't seen any league, I don't believe there's a league that does it just for the money given to them from revenue sharing. Usually it's like, of your total revenue, you have to spend a certain amount on players. That would be one way that you could guarantee this additional money is actually going to increase the quality of the team that you're looking at, right? Because they have to spend it on player salaries. Okay. Any other questions here? Yeah.
I had a question about
yeah.
So the small market team, yeah, that part.
Yep.
Where would the new
profit maximizing point in terms of, well, so, right, we know that it will be lower, right? It has to be that it's lower, right? But you're right. I mean, if I drew it a little bit higher, a little bit lower there, but the main point is that number of wins has decreased. And the amount that it's decreased will be less than the amount it's decreased for large market teams because we know that marginal revenue shift is larger for the large market team if it's based off of percentages. Any other questions on either one of these? Yeah. This one? So this was just saying, I'm only going to, this was what's going to happen if we go from the green scenario where there's no revenue sharing to the red scenario where they then start to take a certain percent of revenue and share it. Now, I didn't draw in the average total revenue curves. Like I wouldn't suggest maybe doing it on your graph because I think it just muddies it up. Or I could draw in like an average total revenue curve here after, because yes, there's a shift downward, but then they're given money back from the league. I wanted to more isolate the impacts of getting money back from the league by only thinking about it happening for one team. So that way we're not getting shifts. We're using these national broadcast deals to then just kind of give the money. But realistically, with revenue sharing instituted, you would see kind of the shift downward, and then you would also get these additional average total revenue curves in there as well. And probably I would have to draw this a little bit smaller to add all that in there. So I wanted to do it in 2 steps there. Is that clear? Any other questions related to either one of those graphs? All right. So that should be good for revenue sharing. I think that should take you, allow you to kind of answer those questions on the homework, kind of completing those last 2. See if we switch over here. Fingers crossed that it does this right. Oh, come on. There we go. All right. So that's why I'd left this kind of blank slide for revenue sharing. I want to make sure we did some review of that. And I'll probably go through the next couple of slides a little bit quicker to get to the next kind of topic. But, we've talked a lot about revenues. It'd be worth mentioning the costs as well. But, when it comes to team costs, really the primary driver is going to be player salaries, right? So you've got other, costs as well, venue, travel costs, right? All of this factors in, but the main cost that you can control and kind of that is variable is player salaries, right? You can kind of change those pretty much year to year. If you sign longer contracts, obviously you're tied into those, but you can kind of go up, spend more on players, to trade players away. And so these player costs are going to be the main thing that they can control. We also want to start thinking about opportunity costs when it comes to thinking about team decisions, though. So teams all face opportunity costs, right? So let's say I look at their balance sheet or kind of the accounting profits that are reported to me are that a team is making $50 million. Right? Maybe let's use the Colts, right? The Colts maybe, let's say, are making, I don't know, this is probably a very low number, but I'm going to say $100 million, right? But that's their accounting profits, right? What's their opportunity costs of being in Indianapolis? Well, they could be playing in a larger city, right? And so over time, if cities start to shrink in size or income in cities starts to go down, that's why we have seen teams shift locations, right? St. Louis Rams said, I'm not generating near enough money in St. Louis. I have this huge, I am generating positive profits, but the opportunity cost of being in St. Louis is not playing in the biggest market, Los Angeles. And even if I'm splitting that largest market, they still must have believed that there were more profits to be made in LA than there were in St. Louis, right? So by staying in St. Louis, they would have had a huge opportunity cost. So if we factor in this opportunity cost, I know I've got it somewhere, right? We're kind of thinking about accounting versus economic profits, right? So the economic profits by staying in St. Louis actually could have been negative. because there was these huge profits they were foregoing by staying in St. Louis. Now, obviously, the decision to move, so I think I had here like a list of teams that have moved. It's not just the profits that I can make in LA. I might have concerns that my demand curve might actually decrease because of fan loyalty or something along those lines. But if I don't believe that that decrease in fan loyalty is going to be that great, right? I think this was probably, if I had to guess, the conversations going on with the Oakland Raiders when they moved over to Las Vegas. I think they probably said, look, we've got a pretty loyal fan base. I mean, I don't even think that one of their stadiums, I don't even think was technically in Oakland. So, so they think that their fans will follow them and that there's just so much more money to be made in Las Vegas that the opportunity cost got too high and eventually they moved, right? But if I think that I'll take a huge hit in fan loyalty, like I'm guessing like if the Boston Red Sox tried to move to, I don't know, Phoenix or somewhere, right? Like I don't think that that's, you wouldn't probably see the fans kind of carry over and you might have a huge decrease in your demand curve there. So they're thinking about costs. They're thinking about opportunity costs when they're making location decisions. We're talking about profits. One thing we have to keep in mind is these teams are owned by owners who are usually multi-million, if not billionaires in some other sectors, right? So when we look at teams and say, well, usually we would say that profits can't be negative, forever. Well, not forever, but if I am an owner of a team and my business or, the stock options I have that are in the company that I started are so large and they're growing year to year, if I can pay for my losses for my sports team with the profit gains from this other sector, then maybe we do see some teams kind of perpetually have negative profits when we look at sports data, right? And even if we're thinking about economic profits there, they could potentially be negative if the owners have enough personal wealth to kind of keep that up. Now, in the long run, what is the long run? But the long run, if we go off into perpetuity, right, owners have a finite age to which there will then be turnover. And so we would expect when that turnover occurs, we then go back to maybe a scenario where they're not able to pay for these negative profits or these losses. I think you had some other examples that are just interesting to think about too. So the Japanese baseball league, basically every team is just a huge marketing tool for big companies there. Every team has a company that's associated with them, and they really look at it as though even if they lose money on it, the gain is going to be from their product, right? They're getting basically marketing out there about their product or their services, and so even if they operate these teams at a profit loss or negative profit, they'll make up for that by the additional sales for their products. Right? So, there's also interesting ties, right? The Anaheim Ducks are owned by, I don't think they currently are, but they were at a time owned by Walt Disney. Maybe they thought that was the same kind of idea. Even if they see some profit losses there, maybe they pick up some additional revenue in non-sports related markets. And so we talked about economic versus accounting profits. There's also some weird things that can go on. If you look at kind of the reported data by teams. So for instance, we talked a little bit about vertical integration. I kind of mentioned the Braves and TBS. So the Braves could basically sell their games at a lower price because basically TBS, owned by the same people, they'd be the ones purchasing it. So why sell it at a markup? Just sell it at kind of cost there. So then my costs are kind of underreported because if I wouldn't have had this vertical integration, I would have had to pay a larger amount for the rights for these games. So sometimes there's some kind of accounting things going on there. Also, especially for you accounting majors, I didn't know this. And then I saw this at one point, or I uncovered that this had occurred. But way back in I think it was right after the Black Sox maybe it was it was real early in Major League Baseball. So maybe 30s, 40s. The White Sox were actually reporting their profits and they were depreciating the value of their players. So even though they were paying players a certain amount of money, they were actually treating them as a depreciating asset. Although that is no longer the case, but that there has been some kind of shenanigans in the past. And so we've got these shenanigans. So maybe we need a league, right? So if you go back far enough, right, there was a little bit of kind of they're operating independently. We need to kind of have a league that kind of is our almost like an arbiter, right? That kind of makes sure that teams are doing things on the up and up. So the goal of a league, right? We've got maybe 30 teams. Why do we need the league? Well, the league tries to push for the common interests across all members, right? So it's trying to kind of do what's best for every team in the league, right? So, maybe this is, wouldn't occur if teams were just having to cooperate on their own. So they also set rules, right? Like this is agreeing that we're all playing the same game under the same set of regulations and rules. So we see that a lot. They set rules, though. A lot of people, maybe don't stop and think about is why, there used to not be a 3-point line in the NBA or in the NBA. And so why did they then institute one? Well, because you can get higher scoring games, right? You get shots that are worth a bit higher number of points. Why might I increase the height of the pitcher's mound? It gives the pitcher a different, advantage or disadvantage based off of the angle to the plate and the height, distance the ball has to travel. And so a lot of times when they play around these rules, they're also thinking about which of these rules will help increase demand for our sport, right? What's another good example of one? I think the overtime kind of in NHL, when they've changed that over, right? Maybe if they believe that people like shootouts more than they like watching additional period, maybe they make that switch because they can then increase demand. Or maybe the NFL says people keep talking about our overtimes and how they're not fair, so they start to alter them, right? They've done that in the recent past, and my guess is that we'll probably have discussions about doing it moving forward as well, right? Because if the fans have negative reactions to things, that's bad for every team in the league, right? So a lot of times these leagues are not just setting rules to be more or less fair. They're trying to generate additional interest into the entirety of the sport. Not one individual team, but every team in the league. So we see teams do that a lot, or leagues do that a lot. They're also kind of concerned with like image issues, right? So, you don't want players betting on your games because you don't want fans to think that everything's rigged and lose interest. Maybe, fans don't think that if there's a fair kind of an even playing field, they lose interest in the sport. So, you might have rules on performance enhancing drugs. You can't have, fans running on the field, right? Setting bad precedent, doesn't look good on the televised games. And so there's all these things that the league's trying to do. And really the main goal is to keep demand for the sport as high as possible. So teams make decisions, right, to increase demand for their team. The league is making decisions to generate increases in demand for the entire sport. So one thing that they might, a lot of leagues will run into is I can't just start like I can't start it because I don't have the money. But if I had enough money, right, let's say Elon Musk, he can't just start an NBA team and start playing with them. Like the league has to accept them as a new team, right? And so you can think about for a league, well, why don't they allow more teams, or why have they in the past, right, went from 30 to 32 or kind of increased in size? Well, let's say that there's no changes in demand, right? If I start adding more teams to my league, eventually what happens? I start getting some pretty bad teams, right? There's only a certain stock of quality that can provide like top level NBA or NFL, whatever sport we're looking at games, right? And so based off of the talent pool and based off of fan interest, and how that changes with the quality of the games being played, I may not want to add just as many teams as I possibly can. There are enough people, there are enough college athletes who would be willing to play, right? It's not like I have a labor shortage issue, right? It's that I don't want to have the quality of my league fall too low, because then I believe I'll see a decrease in fan demand. Okay? So I'm thinking about how are they going to choose the optimal size, right? Or if Elon Musk did want to kind of start a new team, what would be the decision of whether or not they accept that team into the league, right? So as I add more teams, obviously I'm entering into more markets, I'm gaining additional revenue. But what do you think is probably true? Let's say we got rid of the NFL we started 2 new football leagues, and they're both going to like draft the old teams they want to take, kind of going back and forth. What do you think are probably some of the top teams that they would choose? Probably the ones that are the highest revenue earners. So they're probably going to choose teams that are in large markets or kind of have a huge fan base. Like, I'm guessing you'd be like Dallas, LA, right? Like these huge markets where they can make the most revenue. And then as they go back and forth, eventually, right, they're moving down to lower and lower revenue teams. So adding more teams does add additional revenue, but that revenue is declining. So when you think about, if we're thinking about choosing the optimal number of teams, as we choose, allow a higher and higher number of teams, the marginal revenue of each team added begins to decline. Okay. So we're thinking about here, I guess I don't have to stop share because I lost my cord. So let's go over here. This one switches so much slower than the what's downstairs. There we go. So now we're thinking about, okay, what is the product or quantity that we're trying to choose? We're trying to choose the optimal number of teams in this league. Okay. So just kind of said, we're going to have this declining marginal revenue. Each additional team I add adds a smaller and smaller amount of additional revenue. Now it's still positive for all of these, but it is decreasing, right? So that's the idea about what we have going on with marginal revenue. Let's see. So then if we want to think about costs here, as I'm adding a higher number of teams, right, and then having to have an increased number of expenses because I have now more games being played, I have more travel going on, I have, additional, a larger and larger players association, a variety of things that as I'm adding more teams, I'm also going to get this increasing marginal cost, right? And now this really just becomes like everything else really in economics. I mean, in terms of making an optimal decision, you're just weighing out the additional revenue and the additional costs, or the additional benefits and the additional costs to increasing quantity of whatever it is. In this case, it's the number of teams I add to the league. So there, the optimal number of teams here, so we'll call this, I don't know, the optimal number of teams, right, is going to be wherever the marginal cost is equal to the marginal revenue of that last team added. Okay? Pretty simplistic model. So, oops. Let's go back to the slides here. And I'll come back to this here in just a second. So we've got a decreasing marginal revenue. Once we get too many teams, competition starts to get kind of pretty out of whack or not very balanced. Games that aren't balanced, we don't have as much fan interest. And so it's going to be decreasing, right? So I said already, we have these increasing marginal costs. Let me exit out of this. I'm not sure why it's doing that. Is it flashing? There we go. And then in recent years, we've kind of seen, if I can get an increase, so this marginal revenue is based off of fan interest, right? In fact, we could even draw in the demand curve that is kind of based off the demand overall for the sport, right? And so in recent years, it must be that some leagues have actually seen increase in interest because we've seen them increase in size. So one I want to think about is maybe how this operates, not at the professional, but at the collegiate level, right? So if we think about some of these conferences and at the collegiate level, they're all kind of increasing in size, right? The Big Ten is no longer the Big Ten, right? They've had additional schools, right? So why do they do that? And we'll think about specifically in relationship to football, why we've seen this. And I'll kind of give you a nice little graph. I'll also put up this, if you're interested, it's just an old economic theory. It actually applies to anything. So instead of like calling it sport, it's the theory of a club. So it doesn't have to just be a sport club. It could really be any organization where you've got multiple entities, right? So I'll put that up there if you're interested to kind of take a look through it. It kind of discusses kind of some of the issues surrounding choosing the optimal size of a club, right? And the value of members. And it's kind of interesting. So I think here I've left an empty slide. That's what I had drawn before, just a pretty basic kind of graph of how we choose the optimal size of a league. But let's think come back to that in here in just a second. I keep defaulting. So I want to go over one interesting thing with specifically collegiate football that we can think about. So I've got a decreasing marginal revenue from adding more teams and increasing costs. So here we have the number of teams on my x-axis. We've got increasing marginal costs as we add more and more teams. But there's something kind of interesting going on, especially in college football, right? So what's a huge moneymaker that is relatively new in college football? So they had bowl games for a long time, but now they've got kind of the college playoff, right? So they've got 2 games, or kind of like a semifinal. Whoever wins, they then go to the college football playoff, or whatever they call it. Basically, the collegiate Super Bowl, right? It's a national championship game. So one issue is that it's extremely competitive, right? I've got to be one of 4 teams. So I have to play high quality opponents and I have to not lose, right? And if I do lose, right, it better be to a really good team. Also, the number of wins I have matters. So one issue is that when they, this is, if you think about like maybe why the Big Ten did this, right? If they only have 10 teams, they didn't have a national championship game, I need to have 12 teams in order to kind of create 2 different divisions and then have this conference championship, giving whoever wins my conference 1 additional win, making it more likely to get to the national championship game, which means more money is given to our conference. So the teams that make it into the national championship, even actually teams that make it into bowl games, they're given a certain amount of money. So I'm not even really, if I only have 10 teams, it's going to be very hard for me to get one of my teams into that national championship game. So it's almost like I've got this decreasing marginal revenue, but then let's say at 10 teams, right? If I can add this 11th team, because I'm drawing this a little bit incorrectly, right? I should actually be having gaps here, right? Because I can only add one, I can't add 1.5 team, but the idea visually is the same. So I'll see this kind of big jump when I go to add that 11th team or that 12th team. If I think about I'm adding teams in terms of 2, because once I get, and we'll say that, we'll say it's when I add that 12th team instead. So maybe here's the 11th. Then when I add that 12th team, I get a huge jump because the expected revenue now I actually have a chance to get into that national championship game and earn that additional revenue. Whereas if I only had 4 or 5 or 6 teams, I couldn't have this kind of conference championship, or at least that was kind of the conventional wisdom. And so I'll see this huge jump, which now, let's say before, right, without this huge additional kind of increase in revenue, maybe I would have chosen a smaller number of teams. Now, maybe I want to go all the way up to like 15 or 16 teams, right? And so there's this additional revenue that can be made because of having a larger conference. If there's like a threshold amount, well, then potentially that kind of threshold is going to lead to a higher number of optimal teams, right? Maybe something like 16. Now, is the jump that great? Is the difference in revenue that large enough to drive these effects? I don't know. I don't have a good estimates about marginal costs for these leagues or for the NCAA football. But we could start to think about when there is a certain number of games that would then kind of almost like unlock or make additional revenues possible, we might see an increase in that marginal revenue curve. Yeah.
So at first on the original line, it was saying that they only have 10 teams, but now they're thinking that they want 12 for optimal.
Well, it may not be that their optimal was 10. Actually, probably a better way to have done this. I mean, I guess I was making the point that there's a certain number of teams where I then get a jump, right? Marginal revenue kind of takes a jump up because I've almost like unlocked these additional revenues. It wouldn't have been maybe that if I wanted to draw it such that the optimal number was 10, I probably should have had something like my marginal cost curve looks something like this, right? That way the optimal number would be 10, but with this additional revenue that can be made by increasing the size of my league. Well, now once I get to 12, right, I've unlocked this additional revenue and maybe the new optimal number is something like 16. So that's probably a better way to think about 10 being like the optimal point. But I was just going to make the point here. There is a jump at some point, at some number of teams.
questions on this? So this is kind of the optimal, kind of thinking about the optimal size of a league. We'll also think about why some teams might want to limit entry into their league. So everybody okay before I keep moving here? All right, so we'll go back. So if you go back far enough, there used to be in Major League Baseball kind of two leagues, right? The American and National League. So originally there was the National League, and they were limiting the size of their league to 8 teams. And they were in like major Eastern cities, like, people got to go back like over 100 years. So we're talking about like, I think Philly, New York, primarily cities more on the East Coast, right? Over time, gosh, why does it keep doing this? Over time, right? Populations begin to grow, right? Not necessarily as much across the board, but we start to see cities out west in the Midwest really start to increase in population, right? So there were other competing leagues at the time, but they couldn't really compete within the same cities. They couldn't start their own league, using cities like Boston and Philadelphia. They just couldn't compete with the National League. Now, as teams out west started growing population and they weren't, the National League didn't have a presence there, now they could have success out there. So the National League was staying at 8 teams, but then over time, right, the American League began to find success in these cities that were growing in population and really be able to compete and provide as high a quality of product as the National League. Now they've got a competitor. Anytime there's competition, that does what? Well, I'm no longer a monopoly. Being a monopoly allowed me to set higher prices. So more competition, getting rid of that monopoly power, is going to drive down the prices for my products, whether or not that's tickets, apparel, things like that. And so it would have been more optimal if I would have allowed these teams that were kind of in the American League start to join my league. So it must have been that the National League was perceiving their marginal revenue from adding these additional teams incorrectly, right? It's likely they didn't realize the additional revenue that could be made in these new markets. And so, the American League was born, things go on, they eventually joined, but this is really, at the time, the American League came about because the National League was actually making what they thought was an optimal league size decision, but it was actually suboptimal. They should have started allowing more teams into their league, as opposed to kind of allow the introduction of a competitor. So we can kind of think about like maybe a question. I have an online quiz up after today's class, but if we had 2 leagues and they had identical marginal costs, maybe we think about the American and National League and they faced identical marginal costs to adding each additional team. League 1 has a larger number of teams than League 2, then it must be that the marginal revenue of the last team in League 1 is blank, right? So we're thinking here, if we had the same marginal costs, right, and I had one league, League 1 was choosing a larger number of teams, and we're assuming they're making the optimal decision. What would have to be true about League 1's marginal revenue relative to the last league? So let's try to draw this out. What makes sense? So if they're choosing to have a higher number of teams, then what would be true? So let's go think about how we could draw this example out. So I've got these leagues are facing the same marginal cost when it comes to adding additional teams, right? And I know that they're going to make the decision where marginal cost is equal to marginal revenue, okay? So if I've got the marginal revenue of League 2, and I know that they would choose their optimal number of teams here. It was said that League 1 has a larger number of teams. So the only way that League 1 will target a higher optimal number of teams is if their marginal revenue curve is intersecting the marginal cost somewhere over here. Right? So it has to be that the marginal revenue for the league, that's a 1, this is a 2. Marginal revenue for the league that was choosing a higher number of teams, that marginal revenue would have to be larger. Right? in addition to that, right, we can kind of think about the marginal revenue of the last team added would be somewhere up here. So here is the marginal revenue of the last team added for League One. And then the marginal revenue for the last team added was wherever we're at on that marginal revenue curve for League Two. So it must have been a little bit lower for League Two. Which I think the way that the question's phrased is what has to be true about League One? Well, it has to be greater than the marginal revenue from League Two. Any questions on that? Okay. So I might do things like that where I assume like constant marginal cost. That way you're really comparing, you know, if I had difference in marginal cost, then all bets are off there. But because I have the same marginal cost curve, and it doesn't have to be constant, right? It's still increasing. I'm just saying, what if we had an identical marginal cost curve between the two? All right, so I kind of already went over this. We've kind of seen college football increasing. We've got different sizes across different leagues. We talked about kind of why we see more conferences kind of increase to that league size of 12. Anything else that I wanted to say there? I don't think so. I think one thing I didn't add in here, didn't the NHL just added a team last year, right? So I guess we can think about they don't have 30 teams. I believe they now have 31, or do they have 32 because they have 30 because they also added the Las Vegas team, right, in the not too distant past. So they should be in this category now. So it must be that the NHL is seeing an increase in, at least has some markets that are now kind of proving to be profitable. You know, assuming that their marginal cost to adding teams has remained the same, it must be that the marginal revenue from adding additional teams has increased, right? Because they're now allowing a couple of additional teams in. What I want to do, so we got 25 minutes. All right, we'll go over some location stuff, and then I want to show you just some stuff in Excel, how we would do some like linear regression. So it's kind of more related to your projects. Once you get the data, which I've got a couple data sets out there, a couple people have talked to me. Start thinking about that proposal. I believe it's due next Friday, the 11th. Yeah, that's the 11th, I think. Start, if you have questions for me, or if you've got a couple ideas, or like just have a topic and you want to just ask me, and I can try to maybe present you some potential options. So we're thinking about the league and allowing teams to enter, choosing the optimal number of teams. We also want to think about, why do teams end up in the markets that they do, or in the cities that they do? So, leagues realize the power of monopoly. And so they not only want monopoly of the sport, right? They want monopoly in, different areas as well, right? So even if it was teams not in my league, for instance, if I'm trying to add new teams, I don't want to put a team in the city that already has a team, because now they're competing with each other. I want every team to have like regional monopoly power, right? So, but for the teams, I don't care if I have local monopoly power in Muncie, Indiana. I'd rather share, right? I'd rather compete with another team in Chicago, right? So the team's incentives are a little misaligned with the leagues there, right? They may choose to enter a city where there's already a team, while the league realizes like we would desire local monopolies, right? So why do some teams have two teams? Why do some cities have two teams, right? Well, I've kind of mentioned this in the past, I believe, but like if we had large enough demand, there'd be enough to split, where splitting demand in LA is more profitable than having monopoly power in, I don't know, choose a smaller market, Muncie, Indiana, Billings, Montana, or something, right? Or is that in Wyoming or Montana, somewhere out there? So leagues are going to try to protect their existing teams, right? If somebody wants to start a new team and propose to enter, into the league, they're going to try to protect the teams that exist to try to ensure that they keep local, monopoly or regional monopoly power. So every team or every league, not team, every league has a penalty if you move within a certain distance of an existing team, right? I think I put 75 here. I forget which league is which. They're a little bit, the distance is a little bit different for them, but they're all around that, and really trying to protect a new team from moving very close to an existing team. So if you go back far enough, the Nationals, when they moved to Washington, I believe they were in Montreal before, they had to pay the Orioles $75 million, right? Just because they moved within 75 miles. The Rams and Chargers, I've seen different amounts on this, but the total amount paid is going to, and I think they pay it to the league, right? And then the league this might be some of the thing that gets shared and the revenue that gets shared. The Rams and Chargers paid $645 million to move to LA, which just blows my mind. Like, especially since it seems like one of these teams isn't really being welcomed very well. So I would argue maybe these teams aren't always making the optimal decision, but right, apparently they believe that LA was just so big of a market that it justifies the cost if you're going to be there for the next 50 years, right? Because this isn't like a reoccurring cost. This is a one-time kind of upfront fixed cost. So if we look across different leagues, and I didn't update this, but although I think there weren't any moves within the top 10 cities. But if we look at like the top 10 cities, you can kind of see, I organized them here by just city population, metro populations. They might have slightly different orderings, but our largest markets are in terms of population. I think this is like 18.9 million, I think is what that stood for. You kind of see the larger the city, the more teams, and sometimes they have even multiple teams like in the same league. And then as we kind of move down the list, we start to see, okay, some of these, choose not to have, or don't have teams in certain leagues. And if we kept going down the list, right, we just start to see more zeros kind of fill in each row. Right? So I have this data set that I might just throw up on Canvas if you're interested in looking at it. It doesn't just have these top 10. It has, I think, every city that has at least one team in one of these 6 leagues. So it's kind of interesting to take a look at it. Any questions kind of related to anything here? Otherwise, we'll probably start to dive into that Excel data just for the rest of class. And it's not just, we've already kind of discussed, it's not just population here when it comes to location. It would also be based off things like income, probably the age demographics of the area, a variety of other characteristics that would tell me that it's going to be a high demand for my sport in that city. So like, for instance, why might Houston and Atlanta not have an NHL team, but Columbus does? Do people play hockey in Georgia? I mean, I'm sure some people do, but like, it's not a sport that is as popular, right? So there might be regional differences as well. So it might not just be based off of population. It may be based off of kind of regional differences as well. Okay. And those are harder to be completely honest, those are harder to guess and factor in, right? Some of those intangibles. So I put up on Canvas, I think I just dropped it under files. Nope, wait, this is the wrong class. I thought I just dropped it on the files. So this betting data, I kind of threw that up there. It's just an Excel file. So I'll open that up here and we'll take a look at it. So I had, I don't know, some curiosity and thinking about maybe I could outperform Las Vegas and their betting lines. Probably just as smart as thinking you can outperform top mutual fund companies by your selection of what stocks to buy. But it is interesting. You can kind of, we'll play around with this data. So I've got a bunch of different variables in here. Some of them are qualitative, right? They're just words. So like the team, it's got every single game here, what week it was. It's got some weather data for some of these observations. It's got, I don't know, characteristics about the stadium. It's got, I don't know, a bunch of different variables, right? So One thing that I might want to do is take a look at something like, how likely is it that a team covers the point spread based off of kind of what their previous record is, right? Or how likely is it they cover the point spread if, what's another interesting variable? If they're the home team, right? If they're the home team in their favor, right? So you could play around with a bunch of different relationships, but you could start to run some regressions and understand the relationship between kind of these different X variables and whether or not the line that was set in the game, whether or not it was covered. You could also just do whether or not the team won the game, right? You can kind of think about looking at estimates for that. But how would I do that once I have the actual data? Okay. So first of all, I've got a lot of things going on here. So probably good practice. And when you're starting to play around with the data you have in your project, here I usually would do something like rename this sheet as raw data, right? That way it's just like, I'm not going to mess with this. This was the original data before I did any data cleaning. Because you'll notice like there's some missing observations here and I can't use those. They don't have enough information. So I'm going to use a shortcut in Excel. So a lot of you have had 221. If you had me, I tried to walk you through. I'll assume you know a little bit more, or you might know a little bit of something about Excel, but I'll try to mention a lot of these things as well that you may have forgotten. So kind of a nice shortcut is if I hold Control and Shift or Command Shift on a Mac, and then I hit the down arrow and the over arrow, it goes all the way to the last observation and all the way over to the last variable. So it's a nice way to select my entire data set real quick. I'm then going to copy this and then paste that over here. And now I'm going to start to get rid of variables that I don't really care about. Like for instance, schedule date, this came in weird. I'm definitely not going to use that. So I'll get rid of that, right? Just to make it easier to work with. And then from there, it kind of depends on what relationship I want to look at. So let me think of a good one here. Okay, so I want to keep previous covered spread. So I'm going to keep whether or not in the previous game they covered whatever their point spread was. I am then going to look at whether or not they actually covered, right? So we'll get here. I'm going to just delete these. This was previously covered spread, and this is whether or not they actually cover. So actually, this is what I want, previous cover. Okay, this was actually within the same season, right? So how many times they previously covered the spread. So I'm then going to go, and if you don't have this in Excel, you might already have it. We go to File, Options, or I believe on a Mac, there's like a little thing at the top that says like Tools. It's not on Excel, but it's for the Mac tools. So you'll click that instead. Once you do that, you should see a place where you can choose add-ins. Once I've selected add-ins here, I don't think you have to do this step on a Mac, but here on a PC you do. So you hit manage the Excel add-ins, and then you make sure this analysis tool pack has a check mark next to it. Okay. If you have any trouble doing that, like I said, I don't have perfect recall of what it looks like on a Mac. I have walked through the steps, but I think it's tools. Then there's an add-ins thing you can see, and then you go to selecting that analysis tool pack or manage add-ins and then hit the analysis tool pack. So once I do that, under my data tab in Excel, I should have this data analysis pop up. Okay. This is what we're going to use to run our regressions. Right. So we've talked already about some regression equations and looked at papers that have used them, looked at some results. We'll have another one on Thursday, so I'll post that paper as soon as I'm back to my office today. The online quiz that I'll also post once I get back to my office will probably have a question that's related to that, so just making sure that you're at least skimming it to get a general idea of the paper. But we can actually run our own regressions. So I click on that data analysis, I scroll down, I've got a regression option. Hit OK. So I have to select my X and Y variables. So here I'm going to select my Y variable, which was just a 1 if they covered the point spread in this game, and a 0 if they didn't. So we're going to select that. Once again, a nice shortcut. If I hold Control or Command, sorry, I am all messed up. If I hold Control and Shift or Command Shift on a Mac, and then I hit the down arrow, it'll select that entire column for me. I'm then going to click on that X value button or X variable button. I'm going to select the entire column. Now, I also started selecting that variable at the label. So I want to make sure that the labels is selected. If I don't select it, it'll give me some error message here. We can see. Yeah, so it gets mad because I have non-numerical data. You can't run a regression with qualitative variables. Or there'll be some tricks we can do to do that. But for now, like, we can't actually have words in an equation, right? That doesn't, we're not gonna be able to run our regression. So I'm gonna select the labels option because I selected the labels. From here, I think I'm also gonna get another error. I do. So it says they have to have the same number of rows. So I've got an issue. So we got to back out of all this. It's kind of a pain. But if I wanted to quickly investigate this, so I deleted some of these observations, but I'm going to go back over and Control Shift over, down. And then under the data tab, there's also this filter option. So usually I just default, I always turn this filter option on in the raw data. And then also as I copy and paste it, I start to turn it on as well, because it allows me to kind of very quickly look at some things. So if I go up here, once I've selected that filter, after I selected all my variables, notice there's little arrows for every variable now. So I'm going to go over, here was this, did they cover the points they were favored by? And did, how many times in the season did they previously cover those points? I probably want to do something like the percentage here, but that's not the variable I have. So for now, we'll just kind of run with this. So if I click on that arrow, notice it tells me all the values that this variable takes on. But then down here, I've got some blanks. So these blanks are why my regression wasn't running, right? I can't use a variable that I don't have data for some of the observations for. So what I'll do is deselect all of these, click on the blanks, and what it will do is it only shows me the observations where I don't have any data here. And I believe all these were probably like early games, so we didn't have data yet. So then what I'm going to do is I'm going to go over here and just left click and select all of these observations that are blank. Right? I'm then going to just delete those because I can't use them for this regression. Right? Then I go back over. I don't have any blanks now. So now I want to see all of the data that wasn't blank. Okay? So the reason why I said I copy and paste this is because I don't want to be deleting observations, especially if I want to run a couple different regressions where some of them, maybe I have a variable that's missing for some observations, but not for others. And so I always want to make sure that if I'm deleting anything, it's not off of that raw data, right? I hate that I have to delete it here, but it's just not usable, right? It's not a usable data point. So now I've got these two variables. We'll kind of make these bigger so we can see them. Now we go back to data analysis, regression. Okay. I'm going to reselect the variable. So my Y variable is whether or not they covered, 1 if they did, 0 if not. And then here was how many times they previously covered that season. We'll go to, I've selected my labels. I'll hit OK. Now I get this regression output, right? And usually I just default to putting it, I think there's an option. You can put it on the same sheet, or you can just create a new one. I always just use the default of creating a new sheet. So the thing that we're really interested here is going to be what's in column B and also column E. So column B will tell us what the size of the coefficient is. So remember, we said the interpretation of these coefficients is a 1 unit change in my X variable predicts that the Y variable changes by this amount. Well, a couple of things that we haven't talked about. When I have a 1, 0 variable as that left-hand side, that Y or that dependent variable, changes in that, the units are really in the terms of probability. So here, any coefficient I see will be the change in the probability I cover the point spread, right? Because I'm going to be moving from like 0 to 1. So it's the change in the probability I go from 0 to 1. In this case, going from 0 to 1 to be not covering to covering. However, if I increase my X variable by 1 unit, which was how many times I previously covered the spread. If I previously cover the spread one more game, the predicted increase in the probability I cover the next or cover the current game's point spread is only an increase of what, 0.0004 in terms of the probability. So if that's probability, move the decimal 2 places, is about a 0.04% increase, which is pretty small, right? But you know, if you're talking about betting, if you have a large enough money, like that could translate to a pretty good gain. Now the problem is if we look at the p-value, that's not going to be less than our conventional alphas of 0.1, 0.05, or 0.01. So we would fail to reject the null. We said the null for these regressions is we start out assuming there's no relationship. So we start out assuming that, you know, the coefficient, the slope between previous covered the spread and whether or not they cover the spread in the current game, that's 0. Our p-value is not less than alpha, so we can't reject that, right? We don't have strong enough evidence to say that there's any impact from previously covering the spread on whether or not I cover the spread the following game. And these betting lines are set for every individual game, so that ends up usually being what you find. It doesn't matter what happened in the past, right? The people setting these lines are taking that all into consideration, and so each line should be a 50-50 bet, is kind of how betting works. And so sure enough, with a p-value of 0.9, right, we can't say that there's actually an effect here. Now we might say this is pretty naive. Maybe I want to go back and say, well, I want to account for a bunch of other things. You know, I had some, you know, whether or not I cover the point spread probably depends on what the point spread is. So I could go back over, I think I've got some here. Yeah, what was the actual, you know, point spread? What was the weather? I could start to control for the weather here. So I could start to throw in additional variables. So maybe go back over here. And maybe I want to put in, so I'm going to insert a column. Maybe I want to put in the teams. And that's the, here we go. So this is the team that's favored. We want to put in their win percentage, right? So I go back to data analysis. Okay. I've got the same Y variable, so I don't even have to change that. But now I've got 2 X variables that I want to include on the right-hand side. Right? So I'll select both of them, Control Shift, Command Shift on a Mac, hit the down arrow. Got my labels selected, hit OK. And now I get coefficients for both of these, right? So holding constant the win percentage of the team, right, that's favoring the betting line. If they cover now it looks like if they have covered more games in the past, there's actually a negative effect on whether or not they cover it in the current game. Now the p-value is still not less than any of our alphas, but it's starting to get close, right? I mean, 0.13, it's getting pretty close to being significant at the 10% level, right? Or at that alpha of 0.1. But there's also, you know, just including one variable, look how much it changed that coefficient. It's probably that we have a lot of omitted variables. And when we have omitted variables, there's a bias that's built into our coefficients. So we have to be kind of skeptical, especially if we think there's a lot of other things that matter, things like weather, the win percentage of the opposing team, whether or not they've traveled to a different time zone. We do factor in all of these things. Right? But we can do all of that, right? It's just we have to have the variables, and we can throw as many right-hand side variables as we want or select as many as we want in Excel. Okay. Now, another issue that you might run into Excel when we're doing this regression analysis, if you're trying to run your own, is I can't ever select. So I go back in there. I can't ever select X variable. So let's say I want to include this variable and this one. So I can hold, you know, maybe I select this one first. I then go up here and I try to say, oh yeah, but I also want to select this variable, right? So I've selected both of them. The problem is Excel can't do that. So when you do it in Excel, you have to have the variables that you want to include all in consecutive columns. There can't be gaps in between them, right? So that's, once again, why you copy and paste the data, because maybe then I'm inserting and I'm moving my variables around a little bit because I have to get all the ones that I want to include in my regression all next to each other. Okay. Any questions over anything I said or want me to kind of mention again? We'll kind of end on that. So I may be putting up an additional video on YouTube of just some of the stuff that I worked through since I don't know, my cord's gone. But I'll put this up there as well. So if you want to go back through when you start trying this linear regression, you'll kind of have what I've just worked through kind of on that YouTube video as well. If you have any questions over the homework, office hours, I know that we're supposed to get some wild weather, so I will probably be here even if we do. So if you want to come by, I'll be in my office hours tomorrow and Thursday. If there's a time that works better for you, just shoot me an email. We can find a time. I'm pretty available Thursday before class usually. But I don't want to promise I'll be in my office, but if you reach out, I'll let you know if I will be. Other than that, start thinking about those projects. Reach out to me if you have any questions, and I'll see you guys on Thursday.